Okay, so we are still on rectilinear translation, and then for today we're going to discuss about the fifth and the last lesson for rectilinear translation, that is dynamic equilibrium in translation. So analysis as a rigid body. From the previous lesson, that is analysis as a particle. So let's compare between analysis as a rigid body and analysis as a particle. So when we say dynamic equilibrium, this is a condition, no, in which the sum of all forces that acts on a body in motion is equal to zero. So I already discussed this one, wherein I explained to you the difference between a static and dynamic equilibrium. So for dynamic equilibrium, this is for the case if our object is in motion, wherein all the forces that interacts our object, if we sum all those forces, it should be equal to zero. So by the end of this lesson, we need at least two principles, no? So first is the Alembert, and then the second one is the moment principles or the torque principle. So after this lesson, you'll be able to apply these two principles in analyzing and in solving rigid body under dynamic equilibrium in, in translation. So we are not dealing with systems of rigid bodies, unlike from the previous lesson, because it would be very complex to analyze. So in my two examples for this lesson, so we are focused only on a single object, no, and then of course we are going to treat that object as a rigid body, not a particle. So we're going to differentiate, no, these two analysis. First is from the previous discussion, we use this concept wherein if we're given system of rigid bodies or a system of objects, we treat those objects as a particle, so as a point, regardless of their size and dimensions, no. And then of course we all know that we can also represent an object if that object has a reasonable or considerable size, so we treat that one as a rigid body, no, as a rigid body rather than a point or a particle. So what's the difference between these two? So in this first picture, we have here a block that rests on this horizontal surface. Now, if this block is subjected to different forces, the first one colored green, this one is the applied force. Let's say, for example, we pull this block, no, towards the right. Okay, and then of course, assuming that the surface is real, so therefore there is friction that exists between the block, no, between this block and the surface. Okay, so there are lots of forces that interacts, no, but for a simple example lang, no, so let's assume that there are only two forces. Okay, so these forces again is aligned to the direction of motion. Let's assume that the direction of travel, no, is towards the right, no. So from the previous, if we analyze this block as a particle, so this is our assumption. Okay, we treat the block as a single particle in which that particle should be located at the center of gravity, so CG on the second picture. So if the object is assumed as a particle during rectilinear motion analysis, so what we did in the previous discussion in the previous lesson, all the forces that interacts the object is aligned on the axis that coincides the particle. So we align those forces and then we put that one on an axis that is or that coincides our center of gravity. So this is our axis na. Okay. This horizontal axis. And this horizontal axis should be coincide at the center of gravity. So mo na siya atong gibuhat sa previous. Okay? So remember sa problem number 2, no? From the previous lesson, we have two blocks, okay, connected via a rope. And then the other block is hanging. So we treat these three blocks as a particle. So block number 1 connected by the second block, then by the pulley, and then the third one. Okay, ignoring the dimension of this block. And then of course we align those forces that interacts each block at the center of gravity, or in other words sa tunga-tunga sa lawas, no, at the center of its body. Okay, so this is how you do analysis as a particle. However, the main drawback of this analysis is this one. Okay, now there are, of course, in reality, no, uh, there are some objects that are or that possess a considerable size. No, it has a very large dimension. It has a length, no, this one, length and width. Okay, so same forces still have the applied force here and the frictional force. Now, if we try to move this block towards the right by applying a force, now let's say, for example, this force has a distance, no, from the ground, let's say d. Okay. Now, as the distance increases, of course, there's a chance, no. You can also experiment, no, sa inyo if na may block dira. Now mag-attach ka og string. If imo siya i-pull diri nga part, there's a tendency nga kusog ang friction at this corner, no. The friction at this corner is very strong, so there's a chance that this part right here, no, maglutaw na siya, move siya upwards. Okay, so instead of translation, no, so we all know that a body in translation always move, no, parallel, meaning all of its particles. However, in this case, dili na siya pure translation because na particle nga ni rotate na at a certain axis. Okay, so that is why, no, that is why this assumption, no, fails if the object has a considerable size. That is why we need to analyze this one, or we need to treat this block if it has a considerable size, dako na siya, na siya length, na width, very kuana kayo, very significant. So instead of treating this one as a particle, we need to treat this as a rigid body. Okay, so that our computation is valid. So let's proceed to the analysis as a rigid body. Take for example, we have here a block, no, a very large block. It has its height and its length, no, and of course it has a ruler sa bottom. Okay, so ni rest siya sa ato ang in our horizontal surface. So this is how you're going to perform analysis wherein we treat our object as a rigid body. So first is that, of course, we're going to consider all the external forces that interacts our rigid body. Okay, so this is now a rigid body, not an object, not a particle. So rigid body. So we consider all the external forces that are available. So first is of course the weight. No, our body of course has a weight. This one, and since this body, no, is moving at on the surface, no, so there is a frictional force that interacts between the roller, ligid, and the surface. So we have friction number 1 and friction number 2. So for number 1, that is for the roller located on the left, and friction number 2, that is the friction that exists on the roller located on the right. Okay, and what else? So since our body is resting at the top, no, or is moving at the surface or on the surface, so therefore natay normal force, or we call that one as the reaction force. And we have two because naman tay duha ka mga rollers. So we have R1 and R2. What else? So the force that makes this rigid body moves is the applied force, and we denote that one as P1. But of course, the applied forces are not limited only to 2, 3, 4, so on and so forth. So for the purpose of simplicity, let's just assume that we only have one applied force, and that applied force contributes significantly to the motion of our object. That is why this object will move towards the right, okay, or the direction of its acceleration. Now, after having this one, so since this rigid body is moving, of course, it accelerates. So therefore, we need to find, no, the resultant of all these forces. No, we sum up these forces: the frictional force, the weight, if ever na siya component, but obviously it doesn't have a component with respect to the horizontal because the weight always acts vertical, no, in this setup. So the only force that contributes the resultant force along the horizontal are the applied force P1 and the frictional forces. Okay, so you need to know the resultant force and the direction of the resultant force. Always remember from our previous lesson that is parallel to the direction of motion. Okay, so still need to get this one, and in solving the resultant force, it should act at the center of gravity. So even if naanata sa analysis as a rigid body, no, we still need some information from the analysis as a particle, no. Dili nato siya i-ignore ta atong gibuhat kag ganiha. We still need to treat this object as a particle. No, it's part of the process that should be done when analyzing this object as a rigid body. Okay, so sequential siya, dili ingon nga separate ang mga processes that exist in this analysis as a rigid body, but we still get some process nga gikan sa analysis as a particle. Okay, ug unsa na siya nga process? So that is by finding the resultant of all the external forces. So after that, no, it's very kanang difficult to uh, apply, no, apply moments because 'di ba sa atong learning outcome, we need to use the moment principle. Okay, we need to use the moment principle. However, if we use the moment principle here, dili siya valid. It's because uh, we still haven't achieved dynamic equilibrium in this setup. Okay, so how are we going to achieve this one? So we need to get the equilibrium force. So unsay pasabot aning equilibrium force? Actually, this force we cannot see it one. Okay, dili nato siya makit-an. It's because more siya idealized ra nga representation, assuming nga naay mo counteract sa ato ang resultant force. Okay, so if makarepresenta sa kuan sa equilibrium force, no, so that is now the time that we can apply summation of moments. So ay lagkabalaka, the equilibrium force is termed as the REF, no, from the Alimbert's principle. REF stands for reversed effective force. So again, this force we cannot see it, we cannot visualize it, however we can feel it, no, in real nga kanang scenario. Ato ni siya ma-feel, no, kung magsakay tag bus, once mo-move na ang bus, so maka-feel ta nga muratag mo atras. Okay, so kanay mo ma-feel nga mura kag ni atras. Actually that is the reaction, no, of of the of the vehicle that is accelerating. Okay, so that reaction that you just felt is the reverse effective force. So that is why paatras siya. Maunang kung mo-accelerate ang usa ka sakyanan, mura kag atrason. Now, in kuan, in the opposite way, if mo brake pod ang ato ang vehicle, then ang reverse effective force mo bali pod. Kay again, siya gid na mo oppose or mo counteract sa resultant force. Okay? So, ato lang ni siya i-represent. Instead of having this resultant force, just draw the reverse effective force. So, in that way, naanatay unsa man, naanatay pang counteract sa kaning mga forces. So that is why ato lang siya ignore to mga forces because nanata kani siya na balance na ang system. Okay, na balance na. We have the resultant of all those forces nga ako nang gi-erase diri. So mora ni nag-represent niya. And then let's counteract this resultant force by the reverse effective force. Again, they are equal but opposite in direction. So by having the reverse effective force, ato na po itong wad-on. So, diba? Nawa na po diri si resultant. No? Wad-on nimo. So, matong, no? Kuhaon to nimo. Tapos, i-equate nimo sa reverse effective force. Kailangan si REF should be opposite to the resultant. And once nakuha na, so tangtangon na to siya. And then, balikon to nimo mga forces. And after this one, you are now ready to analyze this using dynamic equilibrium. So meaning, gi-assume lang, no, gi-assume lang nga wala nay net force. Okay? Wala nay net force because of this reverse effective force. Kung ato ni tangtangon, okay, naa siya net force. Kung ato ni ibutang ang REF, wala siya net force because REF siya ang nagdala sa net force. So if dili nimo siya i-include sa imo drawing, so this object of course has a net acceleration, that is why nag-move na siya. However, sa imong pag-analyze, if imo ni siya i-include ning reverse effective force, then in that particular setup, that is already in dynamic equilibrium. Kay na kuan man, imo man na equalize tanang mga forces nga nag-interact. So if nahumanan nimo, then you're going to apply moment principle to solve for unknown forces. So, mao man siya ang kasagaran pangitaon sa mga problems. Let's say, for example, you are tasked to solve for the R1, no? Or R2 baka, or the applied force given the acceleration or given the REF. So, the first thing that you should do is take summation. So, how are we going to take the summation of all these forces? So, you can have an arbitrary axis of rotation. So, di ba, sa ato moment, review sa ato statics, kailangan na kay axis of rotation. So, it's up to you. That is why I said it nga arbitrary siya. So, ikaw bahala kung asa ka mag-refer ni ani. It could be here, no? Pwede ka diri or pwede po ka kaning sa iha diri or diri no? Or diri as long as makuha nimo ang mga unknown forces. There are some problems nga hatagan na ka og mga mga points, no? Those are mga mga pivotal points. So you can do summation of moments for that particular kanang kwan pivot point. However, if dili given, then ikaw na mag-analyze, no, kung asa ba siya mo tend ang object to rotate, no? So in that way magamit na nimo ang moment principle. Okay? But don't worry, sa mga problems hatagan jud mga distances na ini. Okay? That is the distance of this force with respect to your pivot point so that you can perform summation of moments. Okay? So, mostly ang requirement sa mga problems no under this topic analysis as a rigid body, mostly ang pangita kay ang mga unknown forces. Okay? Bihira lang siguro ang mga distances pero naay mga cases nga ang distance na pod may mao'y pangitaon. So again, ang nakalahi ra gid ani sa previous lesson is that ngadtoa more on mag-calculate ta sa acceleration or it could be forces, no? But not the distance, no? Or but not the location of these forces because of course sa analysis as a particle sa previous nga lesson ato gi-ignore ang iyahang dimensions. But here we consider its dimension. So para ato ni masabtan, let's have a problem in which ang illustration niya is similar to my discussion kani. So this one, i-block nga nagyapon siya ay mga roller. So the car shown in figure below is given a rightward acceleration of 8.05 feet per second square. So the sum of the frictional forces F1 and F2 under the wheels is 200 pounds. So bali F1 10 pounds, F2 10 pounds. So find the values of R1, R2, and P. So money ang requirement, the applied force P, the reactions at the wheels R1 and R2. So first step is to know all the external forces, but luckily we are already given those external forces. We have the weight 1,000 pounds, we have the applied force P, no? That is 2 feet above the horizontal surface. We have R2, R1, we have the frictional forces at the wheels, and this is the center of gravity located 3 feet above the surface. So, since naa naman, the next step is, saman, kataong gi-explain ko ganiha, that is to find the resultant force, okay? And that resultant force, again, should act at the center of gravity and should follow the direction of motion. So the direction of motion is towards the right man, so therefore mo na siya ang direction sa imong R. So solving for R. Okay? So our R is equal to the summation of forces. So since R is along the horizontal axis, so along horizontal. However, the R is also equal to the weight of the body, the weight of the rigid body, so weight all over the gravity times its acceleration. So we are lucky because the weight is given, no? Of course, G is constant and also the acceleration. So no need na mag-sum sa mga forces along the horizontal. So just use the second formula. We're in weight, 1,000 pounds. Gravity, 32.2. English unit ni siya, feet per second square. And given acceleration, 8.05 feet per second square. Okay, cancel out. So, our resultant force, no? Ato gamitan og calculator. So, we have 1,000 times 8.05 divide by, kuhagan og 0. Divide by 32.2. So, that is 250. 250 pounds. Okay? So, mo na siya ang ato ang resultant force. So, the resultant force is again equal to our equilibrium force, which is our reverse effective force, REF. So, our REF, may act siya opposite sa atong resultant. So, this is now our REF. Okay? So, if we already draw the REF, no? So, ato na lang i-ignore ang resultant force so that we can proceed to summation of moments, no? So, ako nag-delete. So, the second one, we take a summation of moments. So diri sa figure walay gibutang mga pivot points. So para madali inyong pag-solve mo ni ang challenge, you should pick a kanang pivot point in which you can cancel out all those at least ba maka-cancel kag mga unknown forces. Okay, remember that our unknown forces are three: P, R1, and R2. Now if magpili ka og pivot point nga present ang tulo, mas lisod. Okay, lisod kay three unknowns. Let's say for example, if we choose at the center of gravity, this is our moment, this is our pivot point, no? Or the axis of moment. So if we choose this one, mawala si weight, mawala si REF. However, present tanan si P, si R2, and si R1. So this one is not kanang optimal nga kanang kuan nga pivot point. So let's choose another location. So ang ako na choose for optimal nga pag-solve is this one, no? Kaning sa topmost part sa ato ang wheel. Okay? And then sa pagpili pod nimo, no? Sa pagpili pod nimo kailangan mo pili ka og mga locations nga ma-quantify nato. Just like this one, no? This location is 5 feet from the center of gravity and 2 feet above the ground. If you choose somewhere here, di ta ma-quantify ana kung pila may distance ana from the center of gravity. So dili siya optimal nga location. So let's choose this one. Kana akong gikuanan og red, and then ato na siya i-indicate as point A. You can also have this one, kani diri So I chose this because kung inyo analyze, no, walay moment nga mahitabo ni P because P is directly kanang kuan, or P, the direction of P coincides with our axis of rotation, and also R2 ma-cancel siya because ang iyahang axis kay ni coincide sa ato ang pivot point. So therefore, tangtang na ang duha ka unknowns. So we can solve directly for the third unknown, no? R1. Okay? So again, take summation of moment along A, that is equal again sa atong analysis, since this is now a dynamic equilibrium. So the summation of moments at any location within the rigid body should be equal to 0. So 0, and then we treat positive if that force is acting counterclockwise, no, from the pivot point. So CC. So sa A, natay weight, no, or let's start with the reverse effective force, REF. So REF times its moment arm. So the perpendicular distance of point A and the reverse effective force, that is 3 minus 2. Okay? Kaniman siya, mamaya distance, no? This one is 3 minus 2. So that is 1. What else? We also have the weight. So plus the weight and the perpendicular distance of the line of action of the weight and the pivot point A is 5 feet. So 5. Next. So again, akong gi-point out karon is ang mga forces nga nagpa-cause og counterclockwise nga rotation. So paana man gud ni sila ila trend. Now, for the frictional forces kaning duha, so opposite sila, so that is why subtraction sila duha, no? So minus F1 ato sila sum up because they have the same moment arm, that is 2 feet, because the distance of the line of action of both the frictional forces are equal to 2 feet, no? So 2 minus siya because pa-clockwise ang iyahang effect. Now, what else? R1. So si R1 pangadto po diya effect, no, with respect to A. So pa-clockwise manang minus R1, and then the distance of R1 with respect to A, perpendicular distance niya is 10. Okay, then that is equal to 0. So therefore, our R1 is equal to we have REF times 1 plus W times 5 minus F1 plus F2 times 2 divide by 10. Okay? So, REF na to, 250. Tapos times 1 feet. 1 foot. Weight is 1,000 times 5 plus the sum of the frictional forces is 20 pounds. Tapos times 2 divide by 10. So therefore, the first unknown force is equal to, so we have 250 plus 1,000 times 5 plus 20 times 2 divide by 10. So the answer is 529. Sorry. This one is not addition. This one is subtraction. Minus. Okay, so ato utro ko diri So instead of addition, this one right here should be subtraction. Okay, so the answer is 5 to 1. So 5 to 1 pounds. This is for R1. Now to solve for R2, so proceed ta sa next nga slide. So number 3. Again, there are three equations for dynamic equilibrium, no? So dynamic equilibrium, just a review. First, summation of forces along horizontal should be equal to 0. Summation of forces along vertical should be equal to 0, or more or less these equations are also used in static equilibrium. And finally, summation of moment at any point within the rigid body should be equal to 0. So what we did in the previous solution, kaning number 2, we used the summation of moments. Now, in order to solve for R2, no, to solve for R2, we take summation of forces na lang at the horizontal. Okay? So summation forces at the horizontal, that should be equal to 0. And then we treat positive if the forces acts upward. So on sa may mga upward forces, we have R1. So we have R1 plus R2. And then finally the weight, no? Okay, so don't forget to write here REF die. Don't forget to indicate the reverse effective force. Okay, so that is equal to the weight 10,000. So therefore our R2, R1, no, we already solved for R2. Sorry, R2 die, sorry, because R1 madi ato na solve ganyan. So R2 equals 1,000 minus R1, or that is 1,000 minus 5 to 1. 5 to 1 ba to? Okay, so 1,000 minus 5 to 1, and that is equal to 479. Okay, so therefore R2 equals 479 pounds. Okay, next, solving for P. So we already have summation of forces along horizontal, tapos tapon summation moments. Then let's try this one, summation forces vertical. So solving for P, so summation forces at the horizontal should be equal to 0, positive siya if towards the right. So sa may mga forces towards the right, we have P. What else? So P alone. So na ay minus F1 plus F2 ang mga frictional forces minus pa gyud sa reverse effective force. That should be equal to 0. So therefore our P should be equal to F1 plus F2 plus REF. No? And that is equal to the sum of the frictional forces given man 20 pounds. So 20 plus our REF, we already solved that one, no? 250 man siya. So 250. Therefore, our applied force is equal to, that is 270 pounds. Okay? So we already solved the three unknown forces. So just follow these steps. Again, let's review, no? First is dapat i-indicate ang tanang mga external forces. And after that, solving for the resultant, and that resultant should be equal to the REF. Then erase the resultant, retain the REF, and then perform dynamic equilibrium analysis, wherein you're going to use these three equations, very important equation. Summation of forces horizontal should be equal to 0. Summation of forces along vertical is equal to 0. Or summation of moment at any location is equal to 0. But then again, the summation of forces horizontal and the vertical is arbitrary because there are some cases nga naka-inclined no? So therefore, you can change this axis. It could be at a certain axis that is inclined with respect to horizontal. So it's up to you. Okay? So again, at least, I mean, exactly three nga mga equilibrium conditions ang dapat nimo sundan. So kani siya, summation of forces duha o summation moment. Okay, so before we proceed to the second problem, do you have any questions with regards to the first problem? Nay pangutana? I think they nag-chat. Nay pangutana? Sige, sige. Go ahead. Yes, oo. Like, diri ay imong pivot point. Okay? Oo, pwede ra. So, practice ninyo. Usban ninyo ang pivot point. Imo ibutang diri sa B. Still the same gihapon imo makuha. Oo. So, any other questions? Okay, wala. So, proceed ta sa second example. So, the uniform block shown in the figure below weighs 200 pounds. So, it is pulled up the incline by the force of P equals 300 pounds. So, the question is, determine the maximum and minimum values of D so that the block does not tip over as it slides up the incline. So the coefficient of friction is 0.2. By the way, this coefficient of friction is mu k. Now, during our review on statics, we have two types of friction na ma-experience sa object as it moves at a certain surface. So the first one is static friction, that is sa pag-move pa lang, while the second one is the kinetic friction, that is the friction that is being, or that is na-experience sa ato ang object under dynamic condition, or nag-move siya no during motion. So this one, this object, no, this block that rests on the inclined plane, no, we cannot treat this one, no, as a particle. especially nga ang requirement diriya is distance, no? It talks on the distance of one of the external forces. So that is why analysis as a rigid body is the best choice, no, in analyzing this kind of problem or in solving this kind of problem, because na naman siya ay considerable dimensions, no. 4 feet iya height, then 2 feet iya length, and then inclined siya at this angle. This angle, no, implicit iyang pag-defined, no, pinainganig style, pero kumata ani sa ato ang review sa statics, no, kani siya nga triangle. This is 3, 4. This is an Egyptian triangle, no? So this is our theta, the angle of inclination. So automatic, this is 5. So if manginahanglan tag sine theta, that is opposite, so 3/5. And then cosine of theta, that is 4/5. Okay. So diri first, no, is we're going to we're going to determine all the external forces. So first is the applied force, P. Okay. But since our object has a weight, so kailangan imo i-drawing. So the weight from the center of gravity pa downwards siya. This is our weight. We can also resolve our weight sa iyang components normal or perpendicular to the surface. So try ana, and also kanang parallel sa ato ang incline. So if this is our angle theta, kaning parallel sa incline, that this is weight sine of theta, kaning normal, this is weight cosine of theta. Okay, what else? So naman tay coefficient of friction. So ang direction of motion ani is pa upward, no, up the inclined plane, the direction of the acceleration. So therefore our frictional force paana siya, frictional force. What else? Unsa pa may missing diri ang external forces? Okay, the normal force. Again ha, if mag-rest gay ang object sa surface, syempre by Newton's third law, na gina siya ay reaction force. So na ay normal force na may act, no, and this normal force should coincide at the center of gravity of our body. So normal force, and again this is our CG, center of gravity. So by having this one, no, ato na nakuha ng mga norm forces. So the second step is ato i-solve ang resultant. So solving for R. Okay, so R is equal to summation of forces along the axis that is parallel to the direction of motion. So since our direction of motion is along the incline, so ato i-treat nga ang axis sa ato ang incline is xx lang, no? So summation of forces along xx should be equal to the weight of the rigid body over g times the acceleration. So muna akong gingon sa inyo ha. We're not lucky because the acceleration is unknown. So that is why even if nanata sa analysis as a rigid body, we still use some of the processes nga ato pod gigamit sa pag-analyze sa usa ka object as a particle. So diri to solve for acceleration, we need an FBD, no? FBD ani. FBD. So ato na po na siya i-treat og balik as a particle, no? As a particle. So ato na siya gibuhat just to solve for the acceleration only. Okay? It does not affect the calculations of the distances. So ato siya i-assume nga point siya or particle. So again, atong gibuhat sa previous nga discussion, we align all the forces no at the center of gravity. So we have the force P, the frictional force FF, then napasatay component forces sa weight. Ako lay tapa diri ano, ana lang. That is W sine of theta. Okay, I think that's all for the ano, the forces that interacts along the axis XX. Okay. So take summation forces along the axis XX, that is equal to again the mass times the acceleration. Okay. And then we treat positive if the force acts upward up the inclined plane. So we have P minus the frictional force minus the weight sine theta, that is equal to W G times the acceleration. Now, the frictional force, we can also express that one in terms of the coefficient of friction and the normal force, diba? That is mu k normal force minus W sine theta equals WG A. Now, we all know that the normal force, no, if we take summation of forces, no, but so summation forces normal sa incline should be equal to 0. Again, this concept is from the previous lesson, no? Sa katong analysis sa particle nga ang summation of forces along an axis um, that is not the axis of the object's motion, zero na siya dapat, no? Kay ang axis sa object's motion kay axis XX man. So ang kanang axis nga normal sa direction of motion, ang summation of forces ana zero na, dili ingon nga napay acceleration. Okay? Kay remember, ang ato ang body, ang atong object ni translate ra up the inclined plane. So no movement normal to the inclined plane. Mo nang gi-zero ni diri ah. So next, i-treat nimo positive kung pa-upward siya. So the upward force is the normal force while the downward force is the component force of the weight. So that is W cosine of theta. So with this, we have P minus mu k W cosine of theta minus W sine of theta is equals to W over G times the acceleration. So solving for the acceleration is equal to P minus mu k W cosine theta minus W sine of theta divided by the weight all over G. So plug in lang sa mga values, no? So we have P, our P is, that is 300 pounds given man. So 300 pounds minus our coefficient of friction, this one, 0.2. Then cosine theta, our cosine theta is 4/5, so 4 over 5. And then, okay, we forgot to include the weight. So, ato lang ibutan diri 200 minus weight times sine. So, sine theta is 3/5. So, 3 over 5. Then, divided by the weight. So, another 200. Divided by the gravity, 32.2. Okay, our acceleration is 23.828. So our acceleration Tala ibutang diri acceleration equals 23.828. This is feet per second square. Okay? So, next, proceed ta sa third nga step. Ay, sorry. Ang kanipaday, ato na i-complete, no? Dili na nato ibutang. So, by having this acceleration, no? Ato na i-plug in. Ay, diri So, the weight is 200 pounds divided by gravity 32.2 times acceleration 23.828 kay mura man din na atong ikinahanglan. So kani siya, we have the weight times the answer, which is our acceleration divided by 32.2. So the resultant is 148. Mura nga information na to ang kailangan, the resultant. Okay? And again, our resultant is also equal to our reverse effective force. So that if mag-proceed na ta sa ato ang dynamic equilibrium nga solution, dili na si resultant atong ibutang sa center of gravity but si reverse effective force na. So for number 2, again, use the dynamic equilibrium, no? Dynamic equilibrium analysis to solve for the distance d. So duhani siya ka result, the maximum and minimum. So again, this is our center of gravity, CG. Ato isuwat ang mga forces. We have the frictional force, FF. Natay acceleration, A. Then, instead of the resultant, just the reverse effective force. And not only this one, abot na dira ay component forces sa weight. Ako na itapada. Basta kay along ni siya. So, don't get confused. This is W sine of theta. And then, ang paubos, we have W cosine theta. And then, of course, the normal force. Okay, I think para man siguro. Again, sine theta. Our theta here is 3/5. Cosine theta is 4/5. Okay. So, to solve for D, no, if imo siya analyze ang rigid body nga mo-move pa upwards, actually naay duha ka mga points nga mo kani siya mo tip over. Okay, naman diri ano? So mo tip over ni siya. First is at this point, no? Kung imo na siya birahon, di ba? Na tendency nga mo ani iya drawing. May ani siya. Okay? Kung sobraan na pod og bira sa babaw, no? Na ay tendency siya nga mo-rotate pero di gyud siya ingon nga mo-rotate. Ka tendency lang. So mao nang makagamit ta og summation of moments. The second scenario is kung paubsan nimo, may ani pod siya. Tungod kay taas iya center of gravity, dako siya, na chance ubos ra gay ang applied force P, na chance nga mo tip over siya pa downward, not upwards. Okay? So mao nang natay maximum and minimum values of our distance D. Okay? So therefore, ang ato ang mga pivot points, we have pivot point A and then pivot point B. Okay. Start ta sa atong analysis sa pivot point A, no? Summation moment at pivot point A. Okay, sa pivot point A, ato balikon og drawing yung FBD, no? I mean ang iyang kuan, iya scenario. So may ani siya. Ako ra siya gi-exaggerate no, pana siya. So therefore nagyapon tay REF diri as well as the weight sine of theta. And then natay force P na siya ay distance no, distance D. Tapos napod tay diri weight cosine theta. And then si frictional force paana pod. Okay. So akong gineglect no, akong gineglect si normal force because kung mag-analyze tag mga tip over nga mo na siya tendency nga mo turn, imo assumption ani is wala nay contact no, pero di pod mag-change siya, dili mag-change ang atong mga dimensions niya na gi-exaggerate na kung ananay distance so that inyo ma-realize nga wala nay normal force dira. It's because wala nay contacts no, nara ang contact diri sa pivot point. Kung naa dira ang normal force ma-cancel siya because that is our pivot point. That is why wala lang na ako indicate ang normal force no. Mo-occur na siya if mga ani nga na ay tendency nga mo-rotate. So kung mo siya analyze, dapat wala nay normal force ana nga part. Again, sir, ang mga dimensions mao sa ba because na may gap diri Actually dili kay gi-exaggerate nako. Gamay ra kay ang murag gap ana to the point nga ma-preserve gyapon nimo ang mga dimensions nga ma-flat gihapon siya. Ako rin siya gi-drawing ani again para ma-emphasize ninyo nga walay normal force ani. Okay? Kay naa man gud siya ato man siya considered as external forces. Pero pag analyze nato sa summation moments, ignore na siya. So summation moment along A dapat 0 siya. So positive if pa counterclockwise, so CC. So diri unsa may mga forces nga pa counterclockwise, we have the weight no, weight, reverse effective force, and the weight sine theta. Wala tay frictional force kasi frictional force coincide siya sa pivot point A. So we have W sine theta, tapos ihang moment arm kaning half sa height sa ato ang block, so that is 2 plus W cosine theta, tapos iyaha perpendicular distance from point A is half aning width, di ba? So 1. Tapos napatay reverse effective force. So plus REF times same man sa location sa W sine theta, so 2 gihapon, minus P times yang distance from pivot point A is D, should be equal to 0. Rearranging this one, so our P is equal to W sine of theta times 2 plus W cosine theta times 1 plus the REF tapos times 2 feet divide by the distance no, I mean divide by P kay distance pala itong ipangitaan okay, distance, so that is divide by P. So therefore our distance so we can factor out W here. So W again is 200. So our sine theta, that is 3/5. So 3/5 times 2 plus cosine theta is 4/5. So 4/5 times 1 or simply 4/5 plus the reverse effective force 148 man to kaganiha times 2 divide by P, which is 300 pounds. So 300 pounds. So therefore, the answer is 2.32. So 2.32. 2.32. This is feet. Okay? Di pa na ito matel kung pinaka-maximum na bigid ni kay 4 feet pa lang ni basig na paday mas mutaas sa 2.32. Pero kung atong second assumption kaning for letter B nga situation, if mas baba pa sa 2.32, then 2.32 feet is already the maximum value of our height or distance D. So proceed ta sa second nga situation, no? So summation moment at B. Okay? So diri ana at point B. Again, center of gravity. This is REF and W sine of theta. Tapos napunta diri ay W cosine of theta. The frictional force here still neglected kay coincide man iha direction sa atong second pivotal point. And then of course the P. So wala na normal force because kung mag-tip over ta, nagyapoy space, no? Maan agyapon na siya ang scenario ani. Okay? So, nga na, kung nata sa pivot point B. So, there will be no contact between the base and the surface, no? If we assume that it will tend to tip over downward, no? Or down the inclined plane. So, more na yung mga forces, REF, W sine theta, W cosine theta, and our force P. No frictional force because ma-cancelled ma zero iya moment because its direction coincides our pivot point P. So summation moment at B, that should be equal to 0. So we treat positive if makaproduce siya og counterclockwise moment or CC. So na naman si B diri ang makaproduce og counterclockwise moment kay si REF, si W sine. However, for W cosine, clockwise na iya. So we have REF times iya distance from point B is half sa height. So 2 plus W sine theta times 2 kay same naman sila with REF or same with the reverse effective force minus W cosine of theta and the distance, the perpendicular distance of the vector W cosine theta with respect to the pivotal point P, that is half of the width. So that is 1 minus the force P kay makaproduce gyapon siya og clockwise nga moment with respect to B, that is P times iyang perpendicular distance, that is D. That would sum up to 0. So rearranging, solving for D, we have ato lang ni siya gi-transpose, no? So REF plus W sine of theta times 2 minus W cosine of theta. Divide by the force P. So let's see if unsay result niya ani. So we have close parenthesis REF is again 148 plus the weight is 200. Our sine theta, that is 3/5 because this is an Egyptian triangle. Tapos close parenthesis multiplied by 2 minus the weight 200 times cosine theta. So cosine theta is 4/5. 4/5 divide by the force P, which is 300. So the result is 1.25333. So 1.253 na lang approximately 1.253 feet. So therefore, the maximum value is the previous previous value of D nga atong na-solve ko ganiha, 2.32. So 2.32 feet and the minimum value for D is 1.253 feet. So, mo na siya ato ang final answers for the values of the distance D. So, any question? So, ako na ni-end, no?